Hello, my name is Natalia Iaroslavskaia, and I'm here to present to you my problem about series. We need to determine if the series is convergent or divergent. My problem is number 20, summation from n equals to 1 to infinity, n factorial over n to the nth power. In order to find out whether this series is convergent or divergent, we should better use the ratio test because factorial is involved. The ratio test requires us to find the limit of the absolute value of two consecutive partial sums, a sub n plus 1 over a sub n. It's a ratio. And in order to do so, we take to the denominator, we take this expression, but we replace n with n plus 1. So we take n plus first partial sum. And here it is, n plus 1 factorial over n plus 1 to the power n plus 1. And this is our denominator. And in the denominator, we have this expression as it is, n factorial over n to the nth power. So here we see that this is absolute value, but we don't need it as our n goes from 1 to infinity, and we do not subtract or anything that can lead to negative values. So we don't need this absolute value here. And we have multiplying by reciprocal of this expression. We have n plus 1 factorial times n to the nth power over n factorial times n plus 1 to the n plus 1 power. And we can a little bit expand this in order to simplify them. So n plus 1 factorial is basically n plus 1 times n factorial. And over here in the denominator, we also can expand a little bit. It's n plus 1 times n plus 1 to the nth power. And we have items to cancel. N factorial go away, and n plus 1 in both numerator and denominator also go away. So we are left with limit n goes to infinity. In the numerator, we have n to the nth power and n plus 1 to the nth power. And we know from calculus 1 that this limit is equal to 1 over e. It's a remarkable limit. So we have the value that is less than 1. The ratio test states that if we get a value of that limit less than 1, then the series that we examined is convergent. So according to the ratio test, the series is absolutely convergent, thus convergent. And thank you for your attention.